Hello everyone, from the Novedge team, welcome to today's webinar, What's New in Creo 4.0? PTC Creo Parametric 4.0 is PTC's most productive release yet. There are hundreds of enhancements to make your job faster and easier. In this webinar, the focus will be on some of the core enhancements. Topics will include usability, part modeling, 3D print integration with the design of lattice support structure, flexible modeling on sheet metal, and model-based definition. And I also want to remind you that we have a current promotion that will allow you to trade in your inactive, outdated Creo license for a new Creo 4.0 subscription. Our webinar presenter, Andrew Harrison, is an application engineer at PTC with a core focus in the CAD sector. In this role, Andrew works to educate engineers and organizations on the capabilities and value of the Creo Suite so that it can speed up their product development cycle, reduce costs, and improve efficiency. Before we get going, though, I'm going to give you an overview of what we do at Novedge. And as you can see, Novedge is one of the largest online stores for design software. We display Creo. This is the product page. And we offer a huge assortment of software solutions that cater to virtually every designer's need. So check us out. Visit our page at novedge.com. And for more daily software news and limited time promos, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, diving into VR with Vectorworks 2017. Last but not least, today's webinar is free and it's also being recorded live. So if you want to rewatch it, just head on over to Novedge's YouTube and Vimeo channels. And now I'm going to share Andrew's screen so he can take it away from here and tell you all about the new release.
Great, thank you, Barbara. Can you see my screen all right?
Yes, perfect.
Great. So welcome everyone. It's a pleasure for me to be here today and to talk about what's new in Creo 4. So what I wanted to walk through today is kind of what's new with the UI. If you're similar to Creo 3, then it doesn't look like much has changed on the surface, but there's quite a bit that's changed under the hood. So I'm going to also walk through an example of what part modeling would look like in Creo 4, kind of what the new look and feel is, and I think there's some new enhancements we've added in that you're really going to like. We'll also talk about 3D printing. It seems to be on everyone's mind, and we've added in this new lattice design structure so you can build them within your design tool instead of using a third-party tool. And then from there we'll go into some new sheet metal enhancements, being able to leverage flexible modeling, and end with model-based definition and kind of what PTC's approach is to that. So I have this data set of this robot, and we'll be working with that today. And as you can see on the surface here, very similar to Creo 3. So if you're on the Creo platform today, the UI isn't that big of a hurdle to get over, and there are new classes on that. But really how you interact with the model is completely different in Creo 4 compared to previous versions. So even something like selecting on a component here, I get this mini toolbar that pops up. So instead of having to go over to the component and right-click and grab that, I can just select on components as I need, and I get this toolbar. So I don't have to travel very far with my mouse in order to do operations such as activate it or open or start working and changing the definition of the model. Same applies, say, if I turn on my datum planes here and I select on a datum plane, I get this mini toolbar that pops up that now gives me specifics about how I could create an extrusion off of that datum plane and really start working. So with this mini toolbar, we've reduced travel and really the need for the ribbon UI. So another thing new in Creo 4 that we've added is the ability to full screen mode. Either in the bottom left-hand corner or by hitting F11, I can enter a full screen mode here. And so what that does is it really enhances my design space and allows me to work more effectively. And if I need my toolbars or, say, my model tree, I can just drag over to them and they'll pop in as I need them. But because of the mini toolbar now, we can really leverage not requiring the toolbar to be there constantly. So if I wanted to start making an extrude here, say I'm missing the area where this arm comes into the robot, and this is what I want to design today, I could start doing that in full screen mode. So maybe you want to create an extrusion off this datum plane. If we take a look, this is kind of in the middle of the robot, so not really an easy surface. Maybe I want to clear that up. So we've also added in a new clipping model, which allows you to clip directly to where that's at. So it kind of creates a cross-sectional view of where you need it. Now also what we've added in Creo 4, so we have the right mouse button. If I hold down my right mouse button, I get some of my sketch tools. And what we can do is, and if I want to say reference, I'm designing within an assembly today, and I want to reference some of those assembly components and build off of, I could set up my references ahead of time. But what we've added in Creo 4 is the ability to snap. So if I want to borrow some of the geometry here and kind of, use some of the referencing, I can just snap to that. And you can see that take place. So we've really reduced the need to reference as often. And again, if I was going to create a sketch, let's create this sketch here, I can drop straight down. You can see the dotted line, so I get some of that snapping happening as I'm designing, say coming up to the circle now where I want that to be tangentially. So it really does allow you to even sketch quicker than in previous versions. Now if I want tools such as I want to clean up the sketch a bit, I don't really have that off of my right mouse button. So what I can do is I can come up to the ribbon and I can grab the tool that I'd like. So if I want to clean this up and delete some segments, I can do so. So let me finish off this sketch, change the dimensions to what I need them to be, and then we can accept this off again off of that right mouse button. Now this isn't new, but sometimes people aren't familiar with it. So we have this dynamic dragger, and I can select on the open square here, and I can drag my component as I want it. Now what I can also do is, as I'm dragging on this open square, if I hold down my shift key, I can actually say where I'd like that to go to. So I can say, come over here to this washer surface and snap that. So those are functionalities that we have, but that's a quick shift key to do that. What is new, however, is if I hold down my right mouse button, we can drive an extrusion in a second direction. So this was possible in the past, but only for a symmetric extrusion. Now we have this two-sided extrude for all of our modeling process. So I can drive this in that second direction whenever I'd like to. And really what that's going to allow me to do is reduce the amount of features in my model tree and speed up how quickly I want to get that design across. Now this is a bracket component, so let's do a mirror on the other side to complete this off. And again, very quickly, without relying too heavily on my ribbon, I was able to design this in full screen mode. So if we open this up in a separate bracket window, maybe we want to do some more work here. So maybe I want to add another extrusion to the center here between these two bosses. And if we take a look at the side profile, I have a datum plane, but it's kind of offset, so it's not exactly centered where I'd like it to be. Well, what I can do in Creo 4 is I can grab that datum plane and another reference on the side, and I can create a new midplane for that. So it creates a midplane between the two references. And now that's centered where I'd like it to be, and I can design and sketch off of that. So again, I'll just do full screen mode here. And this is a really good area if I wanted to make a rectangle. Maybe I want to add, say, one of the sketch tools in Creo 3 was a center rectangle. Now I might not have that on my sketch tool by default, so what I can do is I can fully customize. Now what we did in Creo 4 is we allowed everything to be customized from the ribbon down to the right mouse button, and not just what would you like to have on the right mouse button, but or reordered, but you can add anything you'd like there. So if I hit customize, here you can see I have all of my commands within Creo that I can add to the right mouse button. And I can simply search for them as well. So if I'd like, say, center rectangle here, I can select on it and just drag it over to my sketch tool and place it where I'd like. Now I already have that button, so I'm not going to add it again, but that's how you would add a new command. And then I can use it as I'd like. So here again, without referencing, I'll use my snap functionality to build that center rectangle there between those two bosses, and I'll accept that off. And then similar, using that, holding down my shift key, I can align it with the side grooves here. And if I'd like that for the back as well, I could do that new drive in a second direction and holding down my shift key, bring that to the back surface. Now, another new thing we did inside of Creo 4 is this new negative offset. So under the options for extrude here, we have these new offset commands. So now I can say, go to the surface, extrude to the surface, but actually offset that a certain degree too. So maybe I want these to be, 1/4 inch offsets on both sides negatively. Then I can add them as well. So I think this new functionality is really going to be able to consolidate some of the features and extrusions you were able to do before. So if you think about how I would design this in Creo 2 or Creo 3, I would have to extrude it in one direction and then extrude that in the second direction and then do an offset on both sides as well. So we're talking about 2 to 4 features, whereas I was able to do it in one feature in Creo 4. So really being able to speed up your design and consolidate how much is in your model tree. Now, the last thing I want to talk about in this part modeling here that's new is we've added the ability to box select inside of Creo. So I can box select from left to right or right to left, and it actually works differently. So if I were to go left to right, everything I fully enclose gets selected, whereas if I go from right to left, everything I touch gets fully selected. But there is box select now inside of Creo 4, something that customers have been asking for and we've delivered on. So again, that's my component, and we can see how that looks inside of our robot now. So it looks good. And again, I was able to design that in about 5 minutes. Now, some new functionality as well that we've added inside of Creo, kind of talking about the usability aspect. If we had to design this robot for different departments or for a marketing campaign, maybe we would need to do something as simple as changing the colors of this. Maybe instead of blue, we want to have some military camo going on and maybe a black one. So how you would do that in the past is you probably either save a copy off multiple times or you simplified representations or some type of family table. What we've done now is in the view manager here, there's a new tab called Appearances, and this allows us to change the appearance colors of our assembly or our model. So here I have this blue one, which I've set up as my default appearance, but I also have a multicam one. So just by selecting and double-clicking on it, I can bring up my multicam robot here. Again, if we look at the options, you can see again under the hood some of the new functionality. So the customization aspect here goes beyond just the ribbon and the quick access toolbar, but all the way to the shortcut keys and so forth. So even at a shortcut key level now, I can map out what shortcut keys I would like to apply to what aspects of Creo right from the UI and under the options here. So quick and easy to do that now. And again, we can apply this not just to the current mode of Creo, so Creo Parametric, but to all modes. So if I go into Creo Simulate, or I go into Creo Layout, I can apply these same customizations there as well. So we've really given the user the ability to tailor the environment to how they would like it. So now what I want to do is transition into kind of our 3D printing and our lattice design structure. So if you take a look actually at this robot arm here, you can see an example of a complex lattice here. Again, it's a little difficult with this multicam, so let me change that back to blue. You can see that 3D lattice we created. And again, this is something new that we've added inside of Creo 4. And so how a customer would achieve this in the past is you would probably add lattice to something that you're looking to manufacture a 3D print for production parts, or you have a need to reduce the weight but maintain strength. And that's where you'd add in a lattice instead of having a solid chunk of plastic. Now, how you would achieve this in the past is you'd have to rely on third-party software. So when you buy a 3D printer, it comes with third-party software that allows you to validate the print and make sure that you have the proper support structure to 3D print, and you can also add in things like lattice structures there as well. The issue we found is, well, if you're validating and you find some issues, now I have to take that data back to my design tool and make those changes and then send it back out to a third-party tool to revalidate. So there's a translation step going on, and you're leaving one system to go to another. And from an IT perspective, that becomes costly for maintaining multiple systems as well as training users on multiple systems. So the idea behind our getting into 3D printing from an integration standpoint and also from a design standpoint is let's start pulling some of that into Creo. That way I'm using one system that I'm already trained on to go from my concept through design and into the manufacturing for 3D printing. So an example of that is we have this robot grip down here. We have these two grippers that, again, I can look at. And if I open that up, so this is a component, and maybe we're taking a look at this and we're looking at the mass properties, and we say, you know what, that mass is a little higher than I'd like it to be for this robot. Maybe we want to look at how can we reduce that. So what we could do inside of Creo 4 is, instead of having this nice solid chunk here, maybe we want to replace this with the lattice structure inside of our robot grip. So I can come in here and I can just blow out that hole. Now I have this nice opening aspect. And what I can do now is say, let's build a lattice. So how I build a lattice in Creo 4 is engineering dropdown, lattice. And what I want to do is define the box that the lattice is going to be built on. So I'll grab that internal intent surface, and then the bottom surface and the top surface. So what it's all enclosed in. And you can see this orange preview of what that lattice will look like. Now we have the ability to size that up or size that down, scale it proportionally. And we can take a quick look at what this would look like as is. So quickly Creo is able to build out that lattice structure. There's some issues if you want to take a look. We have some dangling beams kind of hanging out in space, so maybe we want to clean that up. No problem. We offer options for that. So under the beam and cell list, there are options to change the cell shape, as well as the parameters for each of these. So you can actually get into the actual dimensions of this, and then also toggle buttons. So if I want to remove dangling beams, or I only want the inner vertical beams, or turn off inner horizontal beams, I can do that. As well as the beams themselves. What type of beam would I like? Circular, hexagonal, square, what the cross section would be. So we give you full range on all of this. So if we take a look at what that looks like updated now, we have something a little cleaner. So that's an example of a 3D lattice structure. We also offer a 2.5D, what that looks like, so a little more simplified. We can change that from an X, Y, Z direction standpoint. So here is a rectangle cross-section for this lattice, so we can see what that looks like. You can change that as well from a rectangle to, say, maybe a quasi-radial. We also offer options for the 2.5D of how you can add drain holes as well. So if I'm building a lattice structure internally in my design, I want to think about, as I'm 3D printing, it's going to have support material to build this. But afterwards, I'm probably going to put this in a bath that's going to remove that support material. So how do I do that? I need drain holes. So you can design in the drain holes right away. We can take a look at how that looks as well. So let's apply a 3D regular lattice here and accept that off. And let's look. So the whole mindset here is, let's reduce the weight of this part. Let's reduce the mass. So how much have we reduced the mass by? If we preview that, we can see we've cut off a significant portion, whereas before it was 2.64, now it's 1.74. So a good chunk's been reduced already. Now the question becomes, okay, so I have my mass reduced. Can I withstand the same amount of force though? If it's going to fail, then it's really not worth doing. So how can I test that? Well, within Creo we have Creo Simulate, an integration for FEA analysis. So from here I could assign, say, a material. We have a new Granta design library within Creo 4. So this gives us many more materials to select from. So I can come into this list out of the box and grab some materials I'd like. If we're going to analyze this, actually the lattice itself, if I edit this, has a simplified version which is for analysis. So you can see it simplifies that design down so that it can be analyzed faster than if it was full 3D geometry. And then under applications here inside of Creo, I can just go to my simulate extension. Same UI, now I have tools for how I would simulate this. So let me lock this component down like I would in a physical test lab. And then also apply my force. So this is a gripper, so the force would be on the surfaces down here as it closes, and I can apply, an XYZ component to this force. Preview what that looks like, and accept that off. And then to analyze this, I just go to my analysis studies and say, let's do a new static analysis on this. And let's run that and see what the results look like. So as it's running, I can look at an information, see the passes, see as it goes through until it converges, which it did very quickly in this example, and then take a look at those results. So now I've gone from reducing mass to also analyzing the component to make sure it withstands structural force. And we can see some areas that maybe are problematic. And again, we can change our results around to see what we'd like to view. So maybe what I'm really worried about is displacement in the X direction. Maybe that's something that I really want to take a look at further. So you can quickly gather results, but we can actually go a step further within Creo Simulate with our lattice design. So instead of running an analysis, taking a look at results, making some changes, and then rerunning the analysis, I can actually be more proactive than that. I can actually have Creo look at optimizing my design. So under our design studies, we have an optimization design study. And I can look at what I'd like to do. So what kind of goal do I have? Minimize the total mass is something I'd like to do. What's a design limit? What do I want this component to still withstand? Well, I'm really nervous about that max displacement in the X direction. So say, hey, Creo, minimize the total mass, but don't go beyond a max displacement of this value. And then what dimensions in Creo, what variables can I let it vary? And I could select all of them if I'd like to, even to the lattice structure here. So I can come in, here are the actual dimensions for my lattice structure. And I can grab those, and I can change their variables if I'd like, and those are what Creo can vary for me. And now I can come back in and say, run this. And Creo is going to go run that. So it's going to actually, instead of going one by one and having me check it, Creo is going to now check, have I met my design limit? Am I within the goal? Can I push further? And it's going to run through this. So it's going to do a couple iterations here and check for the results. And again, you could add more dimensions to this, and it's just, it would just increase the amount of iterations Creo would run through and the complexity, but that's the idea of you can actually optimize even a lattice support structure. We can look at that history. Now this changes very little and we don't have the full geometry here, so it's a little tough to tell, but that's how you could run through that. Now once you've analyzed it and it looks good, the next step would be, let's get this 3D printed. So let me change this back to full geometry here. And now let's start focusing on not the design aspect, but how are we going to 3D print this? So in Creo 3 and now in Creo 4 as well, we have integration for 3D printing. So I can say File, Prepare for 3D Print. This could be an assembly. This could be a model. I could have multiple components in here. But now we're looking at how would we 3D print. So we have our printer set up. And actually, we have an office in Greensburg. We have a printer. But you can add more to the printer list here. So simply looking at this, I'm connected up to our 3D printer, so I could connect and print to that. But we could also add a new one. Creo has a support for Stratasys and 3D Systems. So these are two partners that we've connected with, Stratasys and 3D Systems, to offer extended support. But you can validate and look at printing and for any printer. So just by selecting the other, you could do that as well. If you have a Stratasys or a 3D Systems printer, some of these icons are grayed out, so you could apply more, such as the appearance, look at different colors in an assembly, and look at surface finish. So there's additional functionality for those supported printers. You can also directly print from Creo. If we look at other things, so I can position how this would be. If I'd like to have multiple trays, so maybe in my Greensburg printer I'd like to have a couple of these printed out at once, I can add a couple. We also have validation, so global interference. Are any components connecting? Are we going to have any interference? And I purposely had these overlap so you can see that. You could also space them out easily. And then print validation. So this is going to start looking at what are some wall thicknesses, what kind of tolerance, is there any issues we're going to run into? Now's the time to figure them out before I 3D print for 10 hours to bank this, and then realize, oh, I had a thin wall and it collapsed during the print process, so this is a failed component. So here you can see, yeah, I've actually validated thin wall. That's something I'd want to know about and go make a design change on. Now let's say we validated, it looks good, now we want to preview 3D printing. So now I can come in here and I can actually view what's that support structure, what the support material is going to look like, where it's going to fill that in. Also look at the clipping, so how this is going to clip. And then again, if I had a supported printer, I could just print directly from here and it'd go into the print queue. If I don't, all I have to do is say, file save as. 3D printers take an STL file, so right here is the file save as an STL, customize the export, and here I can customize that STL. So here's where I can insert my chord height, my angle controls, which are two important things you need for 3D printing. So just because you don't have a supported printer doesn't mean you can't take advantage of this within Creo. So that is 3D printing integration in Creo 4, as well as our new lattice extension. What I'm going to do now is transition into sheet metal. So what we've done inside of sheet metal in Creo 4 is we've added the ability to utilize flexible modeling. Flexible modeling is an extension we've had for a couple releases now, and it allows for direct editing of geometry. So some areas, Creo Parametric, it's a parametric modeling tool, which means that it relies on relationships. You build dimensions, and it creates parent-children relationships. So if I create a box and then I create a hole within that box, I have to reference an edge for that dimension to drive off of. And it's very good for manufacturing because as things change, they update accordingly because of that design intent you build into it. There are some areas, though, where a parametric tool could fall flat or you could run into some challenges. Those would be working with non-native CAD data, because when I pull in something non-native, I lose the model tree, and so how can I understand the design intent if I don't have the features? Another area is late-stage design changes. I have a part I've designed, we're about to cross the finish line, and we have a significant change that needs to take place. It might be difficult to make that change based upon the intent that I've added into the model. So this area where a direct modeling tool that purely looks at geometry and how can I change and manipulate that geometry comes in handy. And that's what flex modeling is. So it's a DNA of our direct modeling tool that we've pulled over and we found useful inside of Creo Parametric. And now we've applied the same principles to sheet metal. Sheet metal works a little different than a normal plastic part because you need to maintain constant thickness throughout. So now we've added that in for our Creo 4 extension. So if we have these tracks on the side of the robot here, I want to open that. Maybe we want to add a side guard to this. And this is a legacy part. We've had this in the past. We've built a couple robots now. So instead of recreating the wheel, let's go grab the geometry from that side guard. And maybe, before we were on SolidWorks, so this might be a SolidWorks component. That's no problem. I can pull that into Creo 4. I can just natively open that SOLIDWORKS part, and I can assemble it in. And here you can see that side guard as a SOLIDWORKS icon just sitting in my model tree. But taking a look at this, it really doesn't fit our current design. So, I mean, looking at this, it's a little short. We'd probably want to make some changes, at least have it come through the whole track. So it's something I'd want to change, but because it's a SOLIDWORKS component brought in, I don't have my model tree to work off of. So what I can do now in Creo 4 is I can, activate that component. Under operations, say, let's take this SOLIDWORKS part brought over, and this is, looking at this is a sheet metal part, but when it comes over, it doesn't know that. It comes over as a dumb blob. It doesn't have intent. It doesn't have anything in the model tree. It doesn't have any of the features. So we can say, hey, convert this to sheet metal. This is a sheet metal part. Let's make this sheet metal inside of Creo. Because it's a SOLIDWORKS native part, I get a little notification saying, hey, this is native SOLIDWORKS. Would you like to convert it to Creo? I can convert on demand. So if this was an assembly of SOLIDWORKS parts, instead of importing and converting the entire assembly, I can convert just the parts I'd like to change over. So it's going to convert that over to a SOLIDWORKS import component. And now we can say convert to sheet metal. There's a little conversion process. Just really pick what the driving surface is going to be, that first wall. And now it's a sheet metal part. So we have a model tree, and we have the modeling ribbon up top for how we design sheet metal. And here you can see we have one for flexible modeling as well. So within here, I can make transformations. I can grab geometry and say move. I can recognize sheet metal objects such as bends and bend reliefs, and so forth. So if we want to make some changes to this, maybe I want to make this aligned with over here, so drag it to the left. So no problem, I can just say move, I get my 3D dragger, I can relocate where that's at, and I can drag that over to the left. I could drag that a rough dimension or give it an exact dimension of, over to the left 7 inches. Maybe we want to do some more changes here, so let me open this on its own. You can see that the features that I've added in are now stored in the model tree, so anything we do inside of Creo is stored. Maybe we'd like to do some more, so here you can see they've got these cutouts at the bottom. Now that we've increased its length, maybe we want to maintain that consistency throughout. So I'll use the new box select inside of Creo 4. Say, let's pattern that, recognize this pattern of 3. I have the ability under options drop down to also edit these patterns. So I can take this from a pattern of 3 to a pattern of 4 instances, all with flexible modeling. I also have the ability to box select here. So maybe this other component, I'd like to maintain that consistency throughout as well. So I'll just rerun through that pattern and adding a 3rd instance. Maybe there's components I don't want, so maybe these cutouts really don't fit our current design anymore, so let's just get rid of them. So I'll just box select them and hit remove. And they're gone. It's just going to make a nice clean surface there. If I ever need them, it's a feature in my model tree, so I can always bring them back if I like. So we've increased the side here. Maybe we need to do that as well for over here. So I'll select those components. And I'll say, let's move that over. So again, manipulating the geometry as I need it, using flexible modeling on sheet metal. Now there are some specific sheet metal things such as recognize. So recognize bends and bend reliefs. These are things that are prominent for a sheet metal component, and I might need to recognize what they are when I bring in an imported model so that I can edit and change those designs. So recognize bend reliefs. I can do a manual selection, so I can come in here and manually say where bend reliefs are, or I can have Creo automatically find them for me. So it found 8 bend reliefs. And when I say OK, it adds it to this design object tree down here. So here you can see it has those bend reliefs located in my sheet metal component. I could also do that for bends, so I could say, automatically recognize 5 bends found, Now they're added to my design object tree, which now means I can come in here and I could edit these. So here's bend relief 1. I can say, let's edit this relief. And this is the same relief that I would create with traditional sheet metal. So I have my traditional Creo sheet metal reliefs that I can create. If I like to change the shape and so forth, I have those parameters available. I could do the same for other areas as well. So in the front here, maybe I want to change this one as well, edit that bend relief, and change that too. And I can do the same for bends. So we recognize 5 bends here. I can select bends that I'd like to change and manipulate, and I can manipulate them as I need. So with flex modeling and sheet metal now, we've really enhanced how you can work with non-native CAD data, specifically sheet metal, and you can take legacy sheet metal parts and you can update them and you can modify the geometry as you need. Now, we're still in Creo. We still have all of the ribbon for traditional sheet metal too, so I can, of course, not just modify, but I can also add with just sheet metal and Creo Parametric. So we got rid of these punch outs up top. Maybe I want to add in my own. So I could do a sketch form here and add in my own sketch form. Right? So I can always add my own as well. And if we want to, say, pattern this out, we can do that. So I think with Creo 4, being able to modify and work with sheet metal is going to be much easier, specifically if it's coming from a different CAD tool. Barbara, I'm going to take a pause for a second. Is there any questions in the queue?
No, not yet, Andrew. So we're all listening very carefully and taking notes.
Great.
Thank you.
Yep. So we can see that on the track there and then back on the robot. So the last topic that I wanted to talk about today is model-based definition in Creo 4. So model-based definition is working directly off of the 3D model and creating the annotations for that for manufacturing, such as the dimensions, the GD&T, any manufacturing notes or whole callouts, instead of doing them on a drawing. And we've really seen in the industry, especially FA&D, that a lot of companies are going towards this model-based definition, model-based enterprise, as compared to traditional drawings. So we really address that in Creo 4 in a couple of areas. So let me show you an example of what model-based definition looks like inside of Creo 4, and then we'll also talk about a new extension we created. So if I were to look at, say, the 3D annotations for this, we've always had in Creo 2 and Creo 3 this annotation tab. And what we've done is we've updated some of the ribbon UI for dimension and geometric tolerancing. So an example is if I wanted to create some geometric tolerance here, I can come in, select that, and I get this new ribbon UI for how I apply the GD&T. Before, this was kind of the old wildfire interface, and it really didn't make too much sense of where I had to go to apply geometric characteristics and so forth. It was rather difficult. We've heard from customers, and we've made some changes there. So we have this nice new UI that's modernized. So I can quickly say, what's my geometric characteristic here, and I can go change that. So I could say this is flatness. Well, what GD&T value do I need here? I can change my value around. If I need to add any additional text here, I can easily do that, and so forth. If I need to add a datum feature symbols, I can quickly select that and select on the GTOL, and it's going to create that datum feature for me. And it actually has intelligence, so if it's the first datum I'm applying, it's going to go A. If there's already datum A, then it's going to go to datum B, and so forth. So there's some intelligence there as well. Now let's look at a couple other examples here. So maybe I have some annotations for the center hole here, so we can select that. you can see it's already got the plus minus range for it. And maybe now I need to apply the geometric tolerancing to that. So I can say geometric tolerance off of this value, drops it below like standard notation. And again, I can go through and say, what is this? So this one would be perpendicularity. If I need to change that nominal value, if there's any datums associated with that, or if I need to add any symbols. So we have a nice symbol library here, nice drop down filled with different symbols. So maybe I want to apply a couple symbols here as well. So I think we've really made the workflow for applying GD&T much simpler as in the past. And again, I think that really is going to enhance how easily customers can utilize this. So one last example, we could add more notation to this. So an example is we have 4 holes here. Maybe we want to apply the GD&T to that as well. So let me come in here and grab the annotation for that hole. And again, you can see the dimension is updated as well. So the dimension ribbon UI here, very simple. If I want to add tolerance to this, nice tolerance drop down. What type of tolerance would I like? So plus minus. Here I can edit them individually. If I'd like to round specific dimensions, I can do that here. So I could say, you know, how many decimal places would I like that to go out to? And then we have additional text here. So, you know, there's 4 holes, so maybe I want to say 4x that dimension. Here that is. And then if we'd like to apply some GD&T on top of that, we could do that as well. And then again, under additional text here, I could call that out as well. I could say, you know, 4 holes and how I'd like that lined up. So really quick and easy in how we can apply that to our dimensioning. And what I want to say is, so I'm showing this from a model-based definition perspective, so 3D annotations. We've also taken the dimension ribbon UI and the geometric tolerancing UI, so how the look and feel is, and we've applied that to 2D drawings. So if you're still in 2D drawings, you can still benefit from the enhancements we've added. And there's more specific ones for drawings as well, such as nonlinear cross-hatching and being able to embed 2D images into your drawing. Now, let's say that you are a novice at GD&T. So I'm not really too good at applying geometric tolerancing. I don't do it too frequently, or you know, I'm a fresh kid out of college working in a new company. I don't really understand their standards or how they do it. I keep getting models sent back to me to edit and redo. How do I, you know, what's PTC's solution for this? So we've created, in partnership with Sigmetrics, a new extension that we are calling the GD&T Advisor. And again, this was started by Sigmetrics in partnership with them. And what it does is it helps advise and teach and also monitor and take a look at and review how you apply your geometric tolerancing to a model. So how that works is, let's say I want to apply my geometric tolerancing. So I could say, let's do a new tolerance feature and select what reference I would like. So this top surface here. Now it kicks me in and it says, okay, you know, you're missing some things so far for this to be properly defined. So first thing, what's the geometric characteristic? And here you can see it's grayed out all the ones that don't make sense for this. So I can only choose flatness or profile of a surface. So it's teaching me which ones it is as I go through. Same for, you know, the tolerance value. So it's highlighted in yellow. You're missing a tolerance value at the moment. What's the tolerance value? And when I fill that in, now it's good. Now it's going to let me accept that off. And it's even auto-made that datum target A for me. So to show another example, let's create another feature down here. It picks up that hole. It knows what that, you know, dimensional value is so far, but it says I'm missing some stuff. So, you know, what's this one? Is it angularity? Is it perpendicularity? So here I can assign that. What's that value going to be? And, you know, you're missing a symbol as well. And then that dimension, it's, you know, it's nominal at the moment, so we need a plus minus range on that. So let me add that in as well. And it builds out that for me. Now, this will even check your work for you. So let's say that I'm going kind of quickly today, I'm making these, and I'm not really paying attention. So I add my position, I add some value to this, define its symbol, and accept it off. And it looks good, right? It picks up the 8 holes here. But actually, in my advisor tree here, it gives me for this 0.13, it gives me 0 value tolerance not allowed. So I could say, well, what does that mean, right? More help on that, and actually take me to, that's not allowed based upon this standard. It states that you have to have a tolerance range within there. So I say, oh, okay. I just come in here and say, edit that dimension, and I can give it that tolerance range. And now it's happy. So it'll actually check your work for you to make sure that you have the correct standards. And how you can change your standards is under properties here. So right now it's looking at the ASME 14.5 standards from 2009, but you could change that as well. And lastly, to validate your work, what you can do to check that the model is properly defined is I can look at the definition. So is it fully constrained, which would be green? Is it partially constrained, which means you're missing items, or it's unconstrained? So here, as I'm applying my GD&T, I can look to make sure that I am fully constraining my design. So anyone who's new or a novice to applying geometric intolerancing, this is the perfect extension for you. Anyone who is having issues with standards and wants to make sure that they're adhering to standards, this is great for you. And anyone who just wants to validate their work and make sure that they're sending off good models and properly defined, this is really for you as well. So this is new in Creo 4, and it's called the Geometric Tolerancing, or GD&T Advisor. So that's really all I wanted to cover today. What's new in Creo 4? Obviously, there's more enhancements from release to release. We release usually about 400 to 500 enhancements. I picked a couple of the big hitting ones today. I hope you enjoyed what you saw, and now I'll take the opportunity to answer any questions if there are any.
Okay, I'm still waiting for question, Andrew. I don't have any, so I'm going to prompt everybody to, raise your hand. Let us know if you have curiosity, concerns. This is your chance. Andrew, as you can see, is the man. So we'll wait a couple of seconds, and I'm also reminding everybody of the great promotion that will end on March 31st. If you have an inactive Creo license, trade it in and get a new subscription for Creo 4.0. What a deal. And yeah, you've seen what it's capable of. Makes me want 3D print right away as soon as we end the broadcast. And yeah, very exciting features, and a lot of new things, and I hope you're as excited as we are. I don't see any question though. Hold on a second. Do you see my screen, Andrew? Do you still see my screen? I hope you do.
I'm sorry, I dropped my screen.
That's all right.
Yeah.
If you are able to see my screen, I'm happy. You do?
I guess it's still on me. I guess I'm
okay.
Yeah, presenter. So I guess I do not see your screen at the moment.
Okay, let me take. Okay, let me show my
no,
screen.
I do. Yep.
Fantastic. I think you'll all be able to see my screen now. And questions are still not appearing, so I'll take this opportunity to thank everybody for joining this broadcast today. And I want to remind everyone to visit our page at novedge.com, where you can find PTC Creo's new version and also MathCAD. And if you trade in your inactive, outdated Creo license, you can get a new Creo 4.0 subscription. Offer ends on March 31st, so hurry, timing is everything, and Novedge is the best way to buy design software online. For information on specials, new releases, on all sorts of software, join the Novedge network on Facebook, Google+, and Twitter. And next week on our webinar series, we'll host the webinars on virtual reality and Vectorworks 2017. To rewatch today's webinar or previous ones, check out our Novedge YouTube and Vimeo channels. Our webinar playlist as webinar for every software taste. And I don't see any questions. So thank you so much, Andrew. Great job. And yeah, that was so exhaustive. And I hope everybody will take our offer to trade in and will convince somebody to, you know, get on with the new release and start designing and 3D printing and prototyping. Thank you very much, everybody. Have a great day,
Great,
and
thank
thank you,
you.
Andrew. Bye-bye.
Thanks for having me. Bye.
Bye.